All right, so today we're going to explore two real-world scenarios where malicious actors use DNS tunneling to bypass security defenses. Um, Basically, what DNS tunneling is, DNS tunneling is a technique that exploits the DNS protocol to send and receive data through the host or subdomain fields of domain names. It also utilizes a lot of different DNS record types like maybe TXT, MX, or null, which are typically used in DNS for security or descriptive purposes, generally speaking. So that's what we're going to be looking at today. And specifically in this first scenario, we're going to be working within a standard Windows environment where most devices run on Windows 10 or Windows 11. Um, so what we're going to be seeing here is this network, which includes a domain controller and a firewall as well, that is configured to block all traffic except for common web protocols like HTTP, which port 80, HTTPS, port 443, and of course DNS, which is port 53 for that UDP traffic. So under these conditions, generally speaking, it would be nearly impossible or very difficult really for attackers to establish a command and control connection because of those firewall restrictions in theory. That's the idea, right? But what happens with DNS tunneling is that it bypasses this by exploiting the allowed DNS traffic on port 53. It's going to create that channel on port 53, creating that communication between the victim and the attacker's infrastructure. So in this setup, the attacker needs to take control of the authoritative server with a specific domain. And in this case, we're going to use the lab transfer test .site. And in doing that, what they can do is they manipulate the data that's sent to and from the victim's machine. So for visibility, the victim's network has Lumu agents installed on each device. That's, best case scenario in terms of visibility, along with a DNS server collector on the domain controller. There's also the option to have a Lumu virtual appliance in this. It would give you same scenario, same kind of visibility. That's just another option, really. So it doesn't really matter if there's a VA or um, the Lumu agent. Really, either way, you have that same sort of visibility. So the DNS hierarchy, generally speaking, is designed so that when the user requests a website and types in the browser a domain, for example, and it's the first search on that machine, what happens is it searches for the host file. And if the domain is not in the host file and the host name, it's going to ask the local DNS cache in the domain control for that information. So if that domain is not in the cache table, then the recursive server is consulted at that point. And here, that's generally where the ISP server comes into play, or for example, that 8.8.8 from Google. So let's suppose this server doesn't know what the domain is because it's a totally new one, and I have the authoritative server as an attacker. In that case, it's a great scenario for me. It's going to go directly to the authoritative server of the attacker because it's a domain that is new and the attacker controls it at that point. So it can change any response from that domain. And that's really what the attacker wants, to have control over that server of that individual device. So that's the description of what we're going to see today in this scenario. Here on the left side, what we have are two windows. The top one is going to be that Windows machine. This is a totally normal machine. That's what we're looking at on the top side over here, and includes a directory, a very normal, typical machine. In this case, the host name is desktop 75L6B1, 65B1, and the IP for the machine is going to be 172.16.166.132. So the domain resolver in this case is the domain controller that we saw before, but it could be a Lumu virtual appliance, for example. So both the desktop machine and the server have Lumu agents installed. So this machine has a Lumu agent, and the domain controller also has it on the bottom side. And now here on the bottom, we can see the Linux machine that corresponds to the authoritative server. It's in an AWS infrastructure. So really what we have here is the authoritative server of the domain lab transfer test for that site. This server is controlled by the attacker. That's the idea here is this is a cloud instance. It's prepared to host a DNS cat server in the same way that attackers do. So we can see what that looks like. And we're going to execute that in just a minute here through the server. So let's give it just a second. So here in the server, we're going to execute a command. Okay, so here where we have the server that's controlled by the attacker, the window below here, we're going to perform the DNS cat server. So let's go ahead. Here's the tools, DNS cat, CD server. Okay, and all right, so the test domain is going to be DNS transfer test.site over that you see there. That server was written in Ruby on Rails. Okay, so we're going to start it now. And what's happening is that the server is listening for any connection from the victim. Here, what you can see is that the victim's machine is using PowerShell. PowerShell is a really useful tool for administrators and for users, but of course, also for attackers. So this language has a really good advantage, gives them a good advantage. It runs entirely in memory. So we can download the code and execute it without leaving any kind of trace in the system. And a lot of what we're seeing is that many new cyber attack chains are using it. In ransomware gangs, for example, we're seeing that a lot. This technique is also being used a lot in living off the land. That's a common one too. So in this case, the repository is used in the PowerShell for that DNS cat that we're running here. So let's go ahead and download this command to download the DNS cat script and download and charge in memory here. And after that, we can go ahead and then we can start the client. So now it's connected with the GitHub repository and it's downloading the script to execute it after that. So let's give it just a moment. On the right side, what we have is the Lumu portal. And just to give you an idea of where you can find information about DNS tunneling, we have our analytics tab under intelligence. So the analytics tab gives you some general ideas about, what's going on. In anomalies, you have information about the GA behavior, of course. So that's one component. And then the other thing that you have here is the tunneling tab. So the tunneling tab is going to be where you're going to see much of this activity that we're going to be going through in the simulation. So that's where we're going to see all of that different behavior and all of that different everything that's happening in that communication on the left. Okay, all right. So we're pointing now on the left to the DNS cat client here, to the DNS transfer test. That site is the same as the server that we have configured here. So we're going to execute it. And the window on the session is created now. So now, for example, we can create a shell here and have control over this T Simpson machine. So if you can see, the machine is the same. And then who am I? All right, so the laboratory T Simpson is the same. It's the same machine. So for example, we can go ahead and execute it again. Just 1 second. Just give it a quick moment. Okay, we just give it another second. Let's clear it and restart. All right, we're executing a connection in the server again. We're going to create the shell session and give it just a moment. All right. So now one of the things that you can see, it's the connection established here. You can see all of the files in the machine. So for example, you can see the list of files. You can copy paste the different files, for example. So you could see here the structure of those files, everything really from that device of the victim. So at this point, really, the attacker has total control of the client's machine. So now we're going to see what happens in the Lumu portal and how that's detected on the right side here. So let's say this activity happened here. We're going to go back to the analytics tab that we were looking at in tunneling. Okay, so here we can see the event. That is the desktop we've been working with, the desktop 75L6B1. So you can see that host name there, the desktop name. And now if you click on the incident itself, you're going to be able to see the activity here that happened with the ETC. Um, so you see the time there. So at this point, we can see the detection in the victim, right? In the device, what we saw before, the host name. We see that same host name there that matches. We see, basically the information that has been transferred. So this is really about like information transmitted between the victim and the threat actor. So if we want to see more information about this, we can always download the entire CSV file with all of that information about what's happened. So that really gives you a good deal of context around DNS tunneling and that activity. So that is our first scenario with the Windows device. So at this point, what happens? The attacker has total control. But with Lumu and the context that gave you the information, we show you that in real time, what's happened and what's been transmitted in terms of from the customer's device with that DNS tunnel. So that is our first scenario. All right, so this next DNS tunneling scenario involves a hybrid network with a Linux and Windows machine. Typically, what happens is that companies have several local Linux servers like this. And in this attack simulation, it's going to be pretty similar to what we saw with the one in Windows just before this, but it's going to include Linux agents in a Linux environment with Linux servers. So this is a fully Linux DNS tunneling attack simulation scenario. So in Linux environments, it's common to use the iodine tool. Iodine is a really powerful tool that, different than DNSCAT that we saw before, it provides the attacker with the ability to establish a full VPN using the DNS protocol in the 53 port that we saw, but it's going to do this by default this time. So it's a really powerful tool to use. So here on the left side in the client at the top, we're going to run the command to connect. So this is a normal machine without the domain controller. So this machine has a Lumu agent. And the idea here is to simulate to a Linux server or connect to a Linux server with this machine. On the client, we're going to run the command to connect to the Iodine server. So this binary and the commands would be embedded in other binaries in a real attack scenario. But we put the same domain, which has prepared it for the connection and to perform the attack. So on the bottom side, we have the authoritative server with the transfer test and the DNS transfer site domain. So if we perform it, what happens with the Iodine tool, it's going to create a totally new DNS. So as you can see there, the DNS 0 interface there. So local interface. So it's going to have a new IP segment as well, the 10.0.1.1. And in the client, what we're going to do in the device above, we're going to perform the same thing, basically. So one advantage with the iodine tool is that there's actually the option to include a password in that communication. So for example, here we have this pass 123 that you see here, and then in the device above, you have that same pass 123 as well. So you're gonna do that. So now in the client above, we're gonna perform the simulation in the DNS tunnel, and we're just waiting for that connection there. All right, now it's auto detecting a DNS query type because iodine uses a lot of different registers like TXT, MX, and other types that are not really documented by the DNS protocol. Um, so we'll just give it just a second. Now, all right, looks like, so we're going to be able to perform now the tunnel with this command with iodine. And we're going to use that same password and the same domain that's configured in the server. So now we're going to try and connect. It's testing different types of encoding there. And all right, the connection is complete. Now we have another interface. We have a local interface, local network interface configuration. So we have another network segment. You could see it here. The first IP address is 192.168.1.54. So they created for the VPN this segment of the 10.0.1.2. So if I perform a ping to this server, to the 10.0.1.1, we can see that, all right, we have a VPN using the UDP protocol. So this technique is really powerful because we just don't have like a shell session or a DNS cat like we saw in the prior scenario, which is also powerful. But in this case, we have a total connection. It's a fairly big tunnel with the victim for everything that they need. So now, for example, we can evade the defenses of even the LAN network and the AWS network. This is a more evasive approach. It's different in the sense that, it really is able to evade all types of different technologies and in the cloud as well. Because, for example, what you can do is perform this command in the web server with the local environment and using the VPN. So with this new local VPN IP address, really, so it gives you more access to the web server. It really has an open channel of communication because of that. So again, super powerful tool. And because of the fact that that connection was made, now there's really, honestly, unlimited possibilities to perform any kind of attack. So the connection is made there and, can do pretty much anything they want with that device. Now, what we're going to do on the right is go back to that Lumu portal, and we can see how it's detected with the IP of that device. So let's see it here. The IP of the machine. Let's look at that once more. It's that 192.168.1.54. And the activity that we see in the Lumu portal here is the same IP there. So we're going to see the more details. And again, you have all of the data that was transferred. You have the domain, all that information that was transferred back and forth. And the number, like the size of the upload data and the download data. So that basically shows you in both scenarios, really, and in the Lumu portal in general, this DNS tunneling reporting shows you how much data was transferred both ways between the victim's machine and between the attacker's machine. So it gives you an idea of, potentially how much was exfiltrated there. And then, of course, everything's downloadable, but it can also be used, for example, as a proxy for the rest of the network. So that's the second scenario. Again, all this is downloadable and accessible to you.